Multiplying and dividing rational expressions. A rational expression is basically a fraction with a polynomial on top and bottom. All right, for example, if you have something like, I don't know, x plus 3 over x squared minus 7x plus 8. All right, that's got a polynomial on top and a polynomial on bottom, therefore it's a rational expression. It's not a full equation, it's just an expression, it's just a piece of one. A simplified form of a rational expression is one with no, and I'll screw it up, no common factor on top or bottom. There is no common factor in the numerator or the denominator, and the way I'll explain that is you're used to things that we reduce fractions like this. 4 and 8, what can I divide both of those by? You can divide, well, bigger than that, you can go by 4. A 4 over 8 is really a 4 over 4 times 2. All right? Which means, hey, I can cancel because we can divide them both by 4. And it leaves us with a 1/2. All right, the same thing is true with a polynomial. If I've got something like, I don't know, let's do x plus 3 over x plus 4 times x plus 3. We have the exact same polynomial on top and bottom, so we can cancel them out. And we're left with 1 over x plus 4. So that is a simplified rational expression. We have removed any factor that is the same on top and bottom. All right. Now you can have the same thing both on bottom, like 2x plus 4 is on bottom. That's fine, but we don't have the same ones on top and on bottom. All right, and it's the same property as we use to reduce any fraction. We're just canceling out the common numbers on top and bottom. If everything is gone, you put a 1 there. If everything is gone, it's a 1. All right, because it's kind of like saying, hey, all of this is multiplied. It's got a coefficient of 1, right? So if you cancel it all out, the 1 is left over. All right? So the core concept, simplifying rational expressions. The core concept basically goes like this. The property is, hey, if I've got A times C divided by B times C, hey, they both have the same thing on top and bottom. So I can go yoink, yoink, and I'm simply left with A over B. And that is all true whether those represent numbers, whether they represent binomials or polynomials or whatever. If you have the same thing multiplied on top and multiplied on bottom, you can get rid of it. And you can take the example from what we did earlier, or something like this. You can do, I don't know, x minus 2, x plus 3 over x plus 3 times x plus 7. We've got the same thing on top and bottom, so those go away. So you're left with whatever's left on top and whatever's left on bottom. Cool? That is the nuts and bolts of what we're doing today. There's one added thing to this, really, but it's not a big deal. Okay? Whenever you're done writing, flip the page, and we'll keep going. Today is easy. It comes down to, this is the day where you're either, yeah, I already know how to factor, this is dead simple. Or B, I'm going to finally learn how to factor because it's just taking you this long. Or B, I'm going to finally learn how to factor because this is easy and I just haven't learned it yet. Which, that happens too. All right? So here we go, turn the page. Letter A. It says simplify the rational expressions. As of right now, do you have the same thing on top and bottom?
Yeah.
No, you don't.
You forgot the negative.
Huh? You don't. You have different things. So what we're going to do is we're going to factor everything. So let's look at the top. First things first. Can I divide anything out of the top? Well, does this have a 2 out front?
X squared.
Well, does this have an x squared out back? No, I can't divide anything out of that. So let's try the parentheses. What are two things that multiply to the left? x. What are two things that multiply to 12? 3 and 4. Now, can you rig a 3 and 4 to add up to a negative 4? No. So what else multiplies to 12? Can you rig a 6 and 2 to multiply to a negative 4? Yes. What are their signs? Positive 2. Good. For everyone just trying to follow along. Again, left multiplies to left, right multiplies to the right. The outside inside, x times 2, negative 6 times x, and you don't have to write the part in blue, is negative 4. That is our middle term, and that's what our goal is. All right? Just so we're all clear that that is the same thing we've been doing. All right, the bottom. The bottom. What is this middle term right here? It's got an x squared and an x. It is a 0. All right? It's got a 0 in there. So let's do the bottom. What goes on the left?
X.
What multiplies to 4 and adds to 0? Well, 4 and 1, can you get those to add to 0?
1 plus and negative.
One's positive, one's negative. Good. Because that's negative 2x and a positive 2x add up to 0. Cool. That was really the hard part. Do you see the same thing on top and bottom?
Yeah.
What are you left with on top? There's your answer. Easy peasy, chicken greasy. Take a second and try letter C. Letter C. We're skipping B for the moment. Going down to C. Going down to C. Going down to C. He's like, Mr. Hunter, don't. All right, here we go. Let's put it up there. Huh?
So how do you equal 1?
What do you mean, how do you equal 1?
Like, so it had to equal, like the top.
Yes, it had to equal a negative 1 in the middle. Oh, and I forgot to this is a typo right here. This is supposed to be an x squared minus 9. I'm sorry I didn't say that.
Yeah.
Instead of an x to the x. I apologize about that. That is a big typo. But you're right. The outside inside has to equal to a negative 1 in the middle. Cool. Any other questions? Or how are we doing? 5 to 1. 5, I got this form. Okay, 3 and 2, I'm lost 1. Shut the hell up and let me go home. Cool. I got 2 honest people in the room.
Yeah.
And I just said that on the video, but that's okay. Somebody will laugh at me. All right, letter B. Let's go for letter B. Letter B, again, this is another typo. I don't know why I got on there. It's x squared minus 2x. All right, that's what that is. All right, so just... All right, so the top. Is there anything I can do with that? No. It's just a single term.
You can factor the bottom one.
Well, we can do it with the bottom, but the top. Is there anything I can do on the top? No. If it doesn't have any pluses or minuses or anything like that, just leave it alone. So we've got 4x on top. What about the bottom? Can you divide anything out of the bottom?
No. You can factor
The x. The first one has a 1 out front, so I can't divide a number, but I can divide them both by x, right? So I'm going to stick that out front. X subtract 2. Good. X squared over x is just x. Those cancel out, and you're left with a minus 2. Cool. All right. Anything I can cancel out? The x. Good. Because there is no plus or minus out back, I can treat the 4 and the x as individual pieces. So that goes away, and that goes away. And you're left with 4 over x minus 2.
how you divide x by b?
The same. Hey, so basically all we did is we said, hey, x squared minus 2x, we can divide out an x. So I just stuck whatever I divided out front is x minus 2 is what we did. That's how I got this denominator down here.
So if it's like whatever goes into it.
Right, whatever I'm dividing out goes out front. Okay? Whatever's left over goes into parentheses. Okay? That's what's happening there. All All right, letter D. No, I don't want to do letter D. I want to keep moving.
Why?
Why?
Different.
Not really. You want to do letter D?
No. No. I wrote letter B and letter D, so I didn't.
Whatever. I'm sorry. Just put a big arrow. All right, take 30 seconds to do letter D. Take 30 seconds and do letter D. All right, just factor the whole thing. Cancel out anything you can. There are no typos. Yeah, I don't think there are any typos. You make it? Did you get the top part factored?
No, I was confused because I thought we were supposed to multiply and then add or subtract to get the middle number.
Mm-hmm.
But you said something about how sometimes you can't do that. Right?
Sometimes you're right, you can't do that. Sometimes it doesn't work. And if it doesn't work, well then you can't factor it into two pieces. You follow me? If you physically, like, let's say that this right here is a 4 instead of a 3. Well, there's nothing that multiplies to 4 but adds up to 2, no matter how you swing it. I can get to a 3, or I can get to a 5, or I can get to a 0, but I can't get to a 2. And if that's the case, you just leave it as it is. You don't do anything with it. But that's a good question. All right. All right, let's keep on rolling. Let's keep on rolling. All right, multiplying. If we're actually multiplying two of these expressions together, all right, multiplying. If I go like this, if I go, let's say A over C times C over B, okay? And again, those represent numbers or polynomials or whatever. But I can cancel things out across a multiply sign.
So you can cancel C?
I can cancel the C's out. Now, this is not true for a plus, a minus, or a divide. This is only true for a multiply. All right, it's kind of like cross multiplying, but there's no equal sign. So in this case, it's A over B. That's your answer. Okay? And I think they give us kind of a crazy convoluted example for this. But yeah, we can go ahead and do it. So they give us 5x squared over 2xy squared. It's not that hard, it just looks crazy. Times 6xy cubed over 10y. Okay? So let's talk about that for a second. On top, I've got, and I can just treat this as if it was all one big fraction. I can treat it just like that. All right? So I've got 2 x's right here, and I have a third x right there. So I have 3 x's on top. How many x's do I have on bottom? 1. I got 1 right here. So what I'm going to basically do is I'm going to go yoink, yoink. So that leaves an x squared on top. How many y's do you have on top? 3. How many y's do you have on bottom?
3.
You also have 3. Anybody struggling as to why we have 3 on bottom? Okay. I've got a y squared right here, so that's 2 of them. And I have another one, so that's 3 of them all together. Exactly. So I've got 3 on top and I got 3 on bottom, so the 3 on top and the 3 on bottom all cancel each other out. Does that make sense? And then the numbers, I would just multiply across. What's 5 times 6? What's 2 times 10? Alright, so 30 over 20 reduces down to 3 halves.
Wait, so you didn't put the y's in the
Well, the y's all canceled out, right? There were none left over. Because I had 3 on top and 3 on bottom, they all went away. I had 3 right here, and then I had 3 over here, and that was none of them left. The x's, I could cross that one out, but there were 2 left over here. So that's why those carried over.
How do you reduce the 30 and 20?
Well, what is 30 and 20? Divide them both by 10. you get 3 halves. Cool. All right, dividing. Dividing is so much harder. Oh my goodness. It is so much harder. I shouldn't. It's just I'm being massively sarcastic. So let's say I have A over C, and again that's an A, divided by B over C. All right, let's go back to 4th grade. When you're dividing by a fraction, how do you divide by a fraction? You flip it and not mad at it. And multiply. It's the same thing here. I'm going to flip it and it becomes a multiply. And oh, hey, look, now it's just like the problem we just did. Whoa, like totally. That's so, yeah, no. What can I get rid of? The C's. And what's left on top? What's left on bottom? And that's your answer. Okay? If you're dividing, flip whatever's after the divide sign and make it a multiply. That's the only added step. Cool? All right, flip the page. Let's work through a couple of these. Whenever you're done right, flip the page. All right, letter A. I know this looks like a lot. First things first, scratch out this Y. Again, that's a typo, and we're not going to mess with it. All right, so this one's multiplying. So do I have to flip anything?
No.
No. All right, so let's deal with this. How many X's do you have on top?
7.
I have 7. I have an X cubed and an X to the 4th, which makes 7. How many X's do we have on bottom? 1. So if I got 7 on top and 1 on bottom, the 1 on bottom goes away, and how many are left on top? 6. Because it took away one of the ones from the top. Cool? How many Y's you got on top? 3. How many Y's you got on bottom?
3.
So how many are left? None. Good. They all go away. Yoink, yoink, yoink. All right, let's deal with the numbers. What's 8 times 7?
I have no idea.
56. You should have that one memorized. What's 2 times 4? 8. Hey, what's 56 divided by 8?
I'm bad at
7.
So all of that boils down to a 7x to the 6th. Cool?
So you just divide the 8 with 6?
Yeah. But I just did 56 divided by 8. Or really, 56 eighths reduces down to 7 over 1, which is just 7. If that's how you want to think about it, that's fine too.
Okay, you can
Cool.
have to factor for letter B.
Sorry, just like, what's up, Daniel?
You use it as well.
Yeah, I'm just focus on everything separately. Focus on the x's together, focus on the y's together, focus on the units together, on the numbers together. Cool?
I think it's 6.
Because I had 7 of them up top, 3 and 4 make 7, and I had 1 of them on bottom, so that's an x to the 7th on top.
Oh, so you just take out 1.
Cool? All right, A, B, C. Do letter D. Skip down to letter D. It's the one that looks like this one. Knock it out real quick. Knock out letter D right fast. Did you make it? Cool.
Wait.
Wait, I'm confused with the Y.
Okay. Let me erase my hashtag, my hash marks. Okay, so think of it this way. I've got a y squared and I've got 2 y's. So I scratched out the y squared and 2 of the y's. And I forgot to put my y squared up there. Yep. That was left over. Does that answer your question there?
Oh, I didn't know.
Wait, so you keep the X squared?
Yes, because there are 4 of them in bottom and 6 of them on top. And an easier way of thinking of it, hey, these are both a singular x, so I can cancel those out.
But I put,
And then 5 minus 3 is 2. I got 2 left on
but
top.
I put the
Why did
1.
I think 3
Huh?
times 6 was
I put the 1.
X to the 1. Well, I have 6 x's on top, 1, 2, 3, 4, 5, and a 6th. And then I have 4 x's on bottom. 1, 2, 3, 4. And so yoink, 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 yoink. That leaves 2 on top. That's what's going on there.
Yeah, that's what I did, but I left this one here. So
Oh, you left the coefficient on it. That's fine. If you put the coefficient 1 on it, I see what you're saying. All right. Do you want another way of looking at the numbers?
Go.
Okay, here's a different way of looking at the numbers, and for some of you, it'll confuse the mess out of you. Some of you, you'll go, oh, that's so much easier than multiplying up to 72 and then dividing it by 18, that sort of thing. So let's say it was a, what is it? 3, 6, 8, 9. Okay, so you got a 3, a 6, an 8, and a 9. All right? Do you see a number on top and bottom that has a 3 in it? Yeah, 9 is 2 3s, right? It's 3 times 3. So I can cancel that 3 and that 3. Okay. A 6 has a 2 and a 3, so that's a 2 and a 3. So those 3's cancel out. And an 8 is a what times what?
2 times 4.
2 times 4. So hey, the 2's can cancel out. And what's left over? The 4. Kind of a prime factor it and just cancel out the common terms. It's the same idea. Now, if that confuses the mess out of you, multiply them out and factor them. But this is easier for some people. All right? The only problem that I see with this is it can easily become very messy. That's the biggest problem I see with that method. All right? So, yeah. Anyways, all right, let's do another one. Let's do letter B. Scroll up to letter B real fast. Let's start the factoring. Letter B. All right, the top. Can I divide anything out of this?
Yes.
What?
3.
I can divide a 3. Can I divide an x out? Yeah. So I can divide it by 3x. What is 3x divided by 3x? 1. Anything divided by itself is 1. All right, what is negative 3x squared divided by 3x? Close. Negative 3x squared divided by 3x. Well, the 3's cancel out, right?
Yes.
The x canceled out to squared, right? So what are you left with?
X.
A negative x. All right, and if you need to throw some chicken scratch on the side and knock that out, that's fine, but that's what's going on. All right, let's do the bottom. Can you divide anything out of this guy? No. Okay. So what 2 things multiply to the left?
X.
What multiplies to 5? Negative 5, but adds up to 4. 5 and negative 1. Good. All right, let's do the right side. Can you divide anything out of this guy? No. Okay. So what multiplies to the left? What multiplies to negative 20, but adds up to the 1 in the middle? 4 and 5. Which one's positive? Which one's negative? 5 would have to be positive because you need more positive. That's a 7, not a 4. Can you do anything with the 3x?
No.
It's a single term. Don't try to mess with it. All right, factoring out is the hard part. I agree with you. But from here, what can we get rid of? Okay, the x plus 5s can go away.
X plus 5.
The 3x can go away. Yeah, can I get rid of the x minus 1?
No.
Are they the same?
No.
No, because if I put them in the right order, this would be a negative x plus 1 if I switched it around in the right order and got them in the same order. So I cannot get rid of them. So what I'm left with is 1 minus x minus 4, over x minus 1. And that's your answer, which is still a little convoluted, but nowhere near as bad as the original. Okay? What's up? Sure. I think try letter F. I think letter F is the one we want to look at. Is that the one that looks like this? Yeah, do letter F. Skip C and E. Go to F. We'll do C and E in a minute. Right over there. Huh? It's because he's black. Is that what you said?
I'm white.
Totally. He's the whitest African American I've seen in my life. But that's okay.
No, his mom's Hispanic and his dad's
Hispanic and my dad's from Haiti.
Hi.
All right. So here's the deal. Those guys. So let me see. Let me see if I can erase just the marks. All right. So what I've got, because these are just multiplying, I can treat them separately. So the 2's cancel each other out. And this is a single x, but this is 2 x's. So I'm getting rid of the squared part. I'm just leaving 1 x behind. Which, I don't know what happened to the 2 on your screen, but it's on mine. There it is. Cool? But that's what's going on there. All right, here we go. Letter C. Letter C. Letter C. All right. This one has a difference of cubes. We haven't done that in a while. Remember, we can take the cube root of both x cubed and x minus 1. So, let's start with the top. Can I do anything with an x plus 5? Can you divide anything with it? Can you factor anything? No, you can't do anything with it. So we're going to leave that alone. The bottom, that's a difference of cubes. So the cube root of each, well, x cubed is x cubed. So we'll just look at x. What times itself 3 times is negative 1? Don't overthink that one. 1. In this case, a negative 1. Okay? Because negative 1 times negative 1 times negative 1 is a negative 1. All right, and then there's the pattern. Remember the pattern for this? We square the first one, multiply them together and flip it, and then square the back one. You kind of remember that?
Yeah.
At least a little bit. So square the first one. What is x times x? What's x times x?
X squared.
Cool. The next one, what's x times negative 1? Negative x. But then we flip it and it becomes an positive x. So it becomes positive. You multiply them together and then flip the sign. What's the back side? Negative 1 times negative 1 is a positive 1. Good. All right, let's deal with this one. This one on the right. Is that one in the numerator or is that one in the denominator? It's on top. So that's an x squared plus x plus 1 over 1. Cool. If it was in the denominator, it would look like this. That is what it would look like. Cool. So is there anything we can cancel out? Good. The big trinomial over there, which leaves us with what on top?
X plus 5.
Over? Not 1. X minus 1. Cool. Do letter E. It's essentially the same thing, but with different numbers. See if you can pull it off. What's up? All right, there we go.
So you flip the sign for the last one too? At 3 times?
Well, negative 3 times negative 3 is positive 9. So 2 negatives make a positive on that case. Who really cares? You talking about the wall or his shirt? You'll survive, dude. It's a pencil.
Mr. Hunter, the one that is downstairs, what do you get?
Well, everything is over 1, right? So I just wrote it to make sure that you saw that one is in the numerator. Not that you have to write that. I'm just trying to make sure everyone's with us. Yeah, I know. I don't know why it is, but hey, what are you gonna do? All right, any questions on this at all? All right, last one. Letter H. Shh. Letter H. Letter H. How is letter H different than the other ones we've just done? It says division. Okay, what do we do with the division? You flip it. So let's just write that out real quick. So we're going to have 7x over 2x minus 10 times. Put the bottom on top. So x squared minus 11x plus 30. over x squared minus 6x. Cool. And then start factoring. Can I do anything to the 7x? Nope. It's a single term. Leave it alone. Is there anything I can do with the 2x minus 10? What? Huh? Well, can you divide anything out of it?
Oh, 2.
You can pull a 2 out of it. So that leaves 2x divided by 2 is x. And negative 10 divided by 2 is negative 5. And there's no squared, okay? There's no x squared, so we're not going to break it into 2. All right, there's no x squared that's going to stay the way it is. You just might be able to divide it with a number or something like that. All right, let's do the top. Can you divide anything out of it? No. Okay, so we have a squared, so we'll put out parentheses. What goes on the left?
X.
What multiplies to 30 but adds up to 11? Are they positive or are they negative?
Both negative.
They actually have to both be negative. Because to multiply to a positive 30, they have to be the same. All right, and a negative, you owe somebody $6 and you owe somebody $5, you owe $11. All right, let's do the bottom. It's got an x squared, but can you divide anything out?
No.
Yeah, we can pull out an x. So x squared divided by x is x. Negative 6x divided by x is negative 6. Good. Is there an x squared left to deal with on bottom? Is there an x squared on bottom?
No.
No, so you can't go any further. All right, so start slashing. What can we get rid of? X minus 6, x minus 5. What else? The x. Good. Anything else? That's it. So our answer is 7/2. 7/2. Cool? I know you do. That's why I torture you so.